Okay, here we have review exercises for Unit 6. Triangle inequalities possibly are involved, but we're talking about angle bisectors, perpendicular bisectors, and the hinge theorem primarily. So let's see what we have. Scroll up. Okay, order the sides from shortest to longest. So sides that are opposite equal angles, like in an isosceles triangle, are going to be congruent. That's maybe one way of kind of remembering this. So if you have a triangle that's isosceles, the angles that are opposite those equal sides are equal to each other. But with triangle inequalities, you can actually know that the side opposite the smallest angle is going to be the smallest side. The side opposite the largest angle is going to be the largest side. And then you got the middle size side. So sometimes it uses triangle sums to figure out what the other angle is. So these two together add up to 90 degrees. So that means this R angle is a 90-degree angle. The smallest angle is a 44. Next is a 46. And next is the 90. These all do add up to 180, which they're supposed to. The side opposite the 44 is the shortest side. So RS is shorter. The length between R and S is shorter than the length between the side opposite 46, the 46-degree angle, which is QR, which is smaller than the side that's opposite the 90-degree angle, which is QS. One thing to notice is like the 44-degree angle is actually angle Q, a 46-degree angle is S, and the 90-degree angle is R. Notice that the side is RS, but it goes with angle Q. So whichever vertex goes with the angle, the other two vertices are involved in naming the side length, if you're not sure which one it is. So S is the angle, QR are the two remaining vertices. R is the angle, QS are the two remaining vertices. So that's one way to do this if you're a little bit clueless about what's going on. Next one, order the sides from longest to shortest. So longest to shortest this time. So we got to figure out what angle O is. 54 and 61 adds up to 115. Take that away from 180. We get 65 degrees. So this is a 65-degree angle. So the largest angle in this triangle is angle O. Now, if you think about MNO, MN is going to be the side that's opposite that. The next size angle is 61, which is angle M. So we got NO for the side. And then the longest or the biggest angle, although the smallest angle is angle N, the other two vertices that we don't have are MO. So in terms of smallest to largest to middle, that's the order of the side lengths. So usually I would go M and then I look directly opposite and find NO. But also if you're using up M, N and O are the ones that are left. That might be one way to help with some of these. Okay, for these we want to order from smallest to largest again. So this is the converse idea. Angles are also ordered in terms of the sides that they're opposite. So an angle opposite the smallest side is going to be the smallest angle. Angle opposite the biggest side is going to be the biggest angle in the same triangle. So we want smallest to largest. It's important to see which order you want, otherwise it's wrong. The smallest side is AC. So the angle that's missing from ABC with AC being used up is angle B. Angle B is the opposite angle to side AC. So the measure of angle B is smaller than or less than the measure of the angle that's opposite the next size side, which is this CB side, and CB, A is the vertex that's left out. It's less than a measure of angle A. And then the longest side in this triangle is this 3.1 AB side, which goes with angle C as the opposite angle. So we get angle B smallest, angle A medium, angle C largest. Let's look at this one here. Now here, everything's in terms of y. So if we take y out, we've got like a 4, a 5, and a 3 basic ratio between the sides. The biggest side is the 5. Oh, but we want to go smallest to largest. So the smallest side is this 3, which is KL, and so angle J is going to be the smallest angle. The next size number we have is 4, which is the JK, so that goes with angle L as being in the middle. And then the biggest angle is going to be angle K. So those are those angles. I didn't write it down, but I used the triangle sort of as a reference to order them. And all we had to do here, they're all in the same ratio. There's like a 3 to 4 to 5 ratio of side lengths. So we do 3y, 4y, 5y. We could also do times 2, 6, 8, 10, times 3, 9, 12, 15. Those are all basically a 3, 4, 5 type ratio, which would be exactly the same thing. Okay, order the angles from smallest to largest. Now we've got algebraic expressions, so we kind of have to think, like if this is x on the number line, x plus 1 would be over there, x plus 2, x minus 1, x minus 1, x minus 2, and so on. So if we look at a number line, the ones on this side are the largest, the ones on this side are the smallest. So let's see what we got. So x plus 2 is 2 bigger than x and 1 bigger than x plus 1. This is the largest one. The smallest one is going to be our basic x. X goes with xy, so z is opposite angle. Next we got x plus 1, 1 more than x, which is yz side, so x is the opposite angle. That's the medium size side, or angle. And then the largest angle is going to be x plus 2. And the angle opposite x plus 2 is angle y. So it does those for us. Here, we got to figure out what this other side length is here. And this is there's what we call a 3, 4, 5 Pythagorean triple that you should have seen a lot. 9, if we do a squared plus b squared is c squared, we get 9 plus 16 is 25. So that's a right triangle. This is the most basic right triangle that we have that has all integers. The next one up is a 5, 12, 13. 5 squared is 25. 12 squared is 144. And together they add up to 169, which is the square root of 13 is square root of 169 is 13. So this is another Pythagorean triple. So right away, if you see this combination, without doing any work, you would know that that was a 13. Otherwise, you have to do 12 squared and 5 squared, add them together, you get 169. What's the square root of 169? It's 13. Now, in terms of smallest to largest, the smallest side is SR, so angle Q. Now, we can see in terms of the sizes, but this is actually provable because we can use the numbers to order them. QR is a medium size, so angle S is opposite that. And R is the longest side, so angle R, the right angle, is the next, or the largest angle in order in the triangles, in the triangle. Let's move up. In this one, we're looking at whether or not triangles can have this length. So the sum of any two sides has to be greater than the third side to make a triangle. One example might be, so let's say as an example, we had a 3, and we had a 4, and we had a 7 as side lengths, and we wanted to see if we could make a triangle out of these. Since 3 plus 4 adds up to 7, we can't actually, like we lay the 3 down there, we could do something with the 4 here, but the 7 isn't going to reach. All you can really do with these is, just sort of have two. There's not enough of a difference in these to actually make a triangle. It's kind of like the idea. So any combination of two of these has to be bigger than the third one. And we can see that with this one. Okay, so 18 and 16 is bigger than 20. 20 and 18 is bigger than 16. And 20 and 16 is bigger than 18. So that's a yes. Let's look at this next one here. We have 11 and 3 is 14. That's bigger than 7. 11 and 7 is 18. That's bigger than 3. But 3 and 7 makes 10, which is not bigger than 11. So that's going to be a problem, and we can't make a triangle with those side lengths. So all we're doing is checking for pairs of these and making sure that the one that we're not checking at that time is smaller than the sum of those. They can't even be equal, it has to be smaller. Okay, let's move up. They give us the lengths of two sides of a triangle and describe the length of the third side. The third side has to be not bigger than the sum of these, but also not smaller than the difference of these. So for these type problems, you're looking for the sum and the difference. 25 and 10 adds up to 35, and 25 take away 10 is 15. So the third side of the triangle has to be between 35 and 15. Can't be equal to 35, can't be equal to 15, but has to be in between those two. Looking at this next one, 6 and 8 adds up to 14. Let's do it the other way around. The difference of 6 and 8 is 2. So it has to be bigger than 2, not equal to 2, but bigger than 2. And the sum of 6 and 8 is 14. So the third side has to be less than 14. Can't be greater than 14 or equal to 14. And it has to be in between those two. So we'll put the side there in between them. So the lengths find the third side S. So we're looking for the third side S here. So that's basically how we need to do these. You're looking at the sum of the two that they give you and the difference of the two that they give you, and the third side has to be in between those two as an inequality. Let's see what else we got. Okay, on these, let's look and see what we got. So first of all, we have to, for support, like how we know what we can do, how we can do this, is if we kind of look at this BD side here, this BD side between these two triangles, this is a perpendicular bisector. There's the perpendicular angle, there's the right angle that it makes, and here's the two congruent segments. So D is the midpoint, and since this is a right angle at D, it's a perpendicular bisector. And points that are on the perpendicular bisector are equidistant from the side lengths. So that tells us that 4x and 6x minus 10 distances are equal to each other. So we can use the algebra and set them equal to each other and find the x that makes it so. Take away 6x from both sides, minus 2x's is a negative 10. And divide by negative 2, x is going to be 5. Now, wants to know the length of AB. AB is 4 times x. 4 times 5 is 20. So AB equals 20. For this next one, we want to find the length of QR. Again, perpendicular, bisector, equidistant lengths. 3n minus 1 equals 5n minus 7. I'm going to add 1 to both sides and take away 5n from both sides. Minus 2n's is equal to negative 6. Divide by negative 2. N is equal to 3. They want to know what the length of QR is. QR is 5n take away 7. 5n minus 7 equals QR. 5 times 3 take away 7 equals QR. 15 take away 7 is 8. The length of QR is 8. Let's move up. Now these are perpendicular. These are angle bisectors. So let's see what an angle bisector has to do with. So notice that they're showing us that the angle is bisected by this ray MO. So MO ray bisects angle M. Therefore, it's an angle bisector. And a point that's on the angle bisector is equidistant from the sides of the angle measured along the same angle. So these are both a right angle with the side angle. 4x minus 5 distance is equal to 23. So we can use algebra and set those equal to each other and find x. Add 5 to both sides. 4x is 28. Divide by 4, x is equal to 7. Now it wants to know the value of x. X is equal to 7. We're done. Next one, look at it again. Okay, they're showing that it's an angle bisector. Angle bisector is equidistant from the sides. And so 7x must be equal to 2x plus 25. Take away 2x from both sides and then divide. We get 5x is 25. And divide by 5, x is going to be 5. So x is 5 for this one. If we wanted to check, 5 times x is 35. And 2 times 5 plus 25 is 10 plus 25, which also gives us 35. So we can see that it does work out, and those are the same lengths.